Hello and welcome to Train Signal. You are watching a lesson about GNU and Unix commands. Unix is an early operating system dating back to the late 60s that spawned Linux. And though Linux has grown and spawned variants of its own, much of the Unix legacy remains. You'll find this evident not only in the file system, but also in the commands. GNU, and there is some debate around the correct pronunciation of this term too, is an acronym for GNU's Not Unix. It was launched in 1984 to develop a free Unix-like operating system. What started out as GNU Linux has been shortened to just Linux. Unix was a command line based operating system, and though modern Linux distributions feature a GUI interface, as we've learned over the last several lessons, the real power rests behind the scenes, at the command line. Now, while regular users may spend very little time lurking around in such unknown waters, the command line is where an administrator must thrive. So in this lesson, we'll take a closer look at the command line. We'll review text streams and filters that alter command line output. Then we'll take a look at basic file management commands and pipes and redirects which are used to manipulate input and output. Next, we'll review how to identify and control Linux processes, how to use regular expressions, and wrap up with a look at Linux's Vi text editor. Let's get started with the Linux command line. When we launch a terminal window, you're working in what's called the shell environment. From the shell, you type in commands at the keyboard in order to interact with the operating system, similar to the actions you'd perform with the mouse in a GUI environment. Some of you may be familiar with the DOS shell, command.com, but Linux actually has many shells. The most common is Bash, or Born Again Shell, sometimes symbolically linked to BSH. This is the shell you should focus on in preparation for the Linux Plus exams. I'll quickly go over the others. TCSH is based on the C shell, which uses a syntax similar to the C programming language, but it isn't the default for any Linux distributions at this point. KSH, or the Korn shell, combines the best of Bash and C, while ZSH, or Z shell, is designed as another Korn shell improvement. Chances are you're running the Bash shell, but to verify, just type in env at the command prompt. The image on your screen shows the output from this command, and a few lines down from the top of the listing, you'll see the line that begins shell equals bin bash, and that tells us we're running the Bash shell. Now you can run both internal, those built into the shell environment, and external commands from the shell. Let's review these on the next slide and then try out a few in our terminal window. The first command is one you should be pretty familiar with. It's cd, which changes the current working directory. The next is pwd, which will display the working directory. Echo will write the text that you enter to the screen. Now this will come in handy later on when we talk about writing scripts. Another function of echo is to show the current value of the path command. With echo space $path, and the $sign tells echo that the text after it is a variable. Exec runs an external program. However, it's probably better just to execute the program by typing the name, and exec does replace the shell when the program is run, so when you terminate that process, it's just like terminating the shell. Time tells you how long any subsequent commands take to execute. Set will display options related to Bash operation. And finally, exit and logout terminate the shell. Exit will terminate any shell, but logout only works for login shells, and login shells are those launched when you enter a text mode login. And this is not an exhaustive list by any means. You can consult your shell's help documentation for more commands, and we'll touch on a few others in later lessons. I'd like to note a couple things about paths in Linux, which is totally different from the way paths are handled in Windows. Linux has a path variable, which can be set, and we'll talk about that a little later, but when executing a file, Linux does not check the current directory. It only checks the directories indicated by the path variable. So if you're in your home directory, but the executable you want is located in another directory altogether, you'll get an error unless you enter the full path to the command or switch to the right directory. The contents of the path variable will be shown as part of the output from the env command we just discussed. And there's another important note about paths. Now there may be a time as an administrator when you need to edit the root user's path. And one directory that should never be included in root or even a regular user's path is the current directory, indicated by // This could allow an intruder to trick root into running replacements for common programs. Okay, let's switch over to a terminal window and try out a few shell commands. From our Applications menu and System Tools, let's hit Terminal. First, let's check out our current working directory. Type in pwd and hit Enter. And we can see that our current working directory is home v Henry. Now let's move to another directory. So type in ls. Now this is a command we'll cover in more detail later, but it will display the list of contents of the directory. So let's hit Enter. Okay, so say we wanted to switch to the Downloads directory. We'll type in cd space capital D Downloads and hit Enter, and we can see that our prompt indicates the change. Remember that Linux is a case-sensitive operating system, so typing in Downloads with a lowercase d would yield an error. Next, let's try the echo command. First, let's clear the screen with clear. Then we'll type in echo, E-C-H-O, space, hello, and hit Enter. And you can see the hello was echoed on the screen. Okay, let's head back to the presentation and talk about navigating the shell, editing the configuration, and a little more about environment variables. While your users will likely balk at the idea of using the command line, it's essential for administrators. After experiencing a broken X or GUI configuration and only having the ability to boot into a shell, I learned this lesson the hard way. But there are ways to make navigating the shell a little easier. The first of these tricks is called command completion. You simply type in part of the command and hit the Tab key. The shell will try, often successfully, to find and complete the command or file name for you. Another very helpful tool is history. History keeps track of every command you type and stores it in _history. So if you've typed in a long command that you need to repeat, or you've accidentally omitted a character, just press the up arrow key, and that will display the last command. Down arrow, of course, lets you move backwards. Let's switch back to our terminal window for a moment. Let's hit the up arrow key a few times. We'll see that it brings up all the commands that we've typed. And if you like to execute the same command, all you have to do is hit Enter. Moving on, Ctrl+R allows you to do a backward search, while Ctrl+S searches forward. Ctrl+G terminates the search. And here are a few line editing tricks. Ctrl+A or Ctrl+E moves the cursor to the start or end of the line respectively. Left or right, also Ctrl+B and Ctrl+F, move one character at a time. Ctrl+D, or hitting the delete key, deletes the character the cursor is on, and backspace deletes the character to the left of the cursor. Ctrl+K deletes all text from the cursor to the end of the line, and Ctrl+X, and then backspace, deletes all text from the cursor to the beginning of the line. Ctrl+T transposes the character before the cursor with the character that the cursor is on. And finally, Escape, and then T, transposes the two words immediately before or on the cursor. You should be familiar with the concept of configuration files by now. Like many other Linux programs, the shell has its own configuration files. For individual users, it's home.bash.rc or home.profile. And the global configuration file, and that's one that's used for all users, is at etc bash.bashrc or etc profile. We'll cover these in more depth in a later lesson. We've touched on the environment variables just a bit. They're just like variables that you'll find in programming. They're like little information holders, which can be referred to by a name you designate. We'll also cover this topic later, but while we're talking about bash, you should understand that you can set variables with the equal sign and then the export command. For example, to set a variable, my variable, to a website, you might type in something like export space my variable equals my.newserver.com. We know that to get help with any Linux command, we use the man command, along with the less pager. But what we haven't talked about is that man pages are categorized into sections numbered 1 through 9. And searches will usually return the first hit on the lowest section. But you can look into a specific section with the man number command. Now, section 1 contains help for executable programs and shell commands. Section 2 for system calls provided by the kernel. Section 3 is for library calls. 4, device files. 5 is for file formats. 6 for games. 7 is miscellaneous. 8 is for system admin commands. And 9 is for kernel routines. And it should be noted that some programs now use info pages, which are accessed just like man. You type in info followed by the command. We've already talked a little bit about pipes, which allow you to take the output of one command and use it as the input for another. The syntax is simply file, pipe, file. That was one command line tool, but as you've guessed, there are many others. Input and output sent to and from your computer is treated as a stream, and this stream can be even further manipulated. One of the cool things you can do is redirect it to a file. There are 3 types of streams that we'll focus on. The first is standard input. Now this is the data that comes to the computer via the keyboard. The next is standard output, which is data from text mode programs that's displayed on the screen. And standard error carries high priority information like error messages, which is usually sent to the screen but can also be redirected to a file for later viewing. The T command is often used with pipes as it can display information via standard output and also multiple files. As an example, if you typed in run prog space pipe space t space new file.txt, the program would display the output on screen and also copy it to new file.txt. Another command is xargs, which builds a command from standard input. The syntax is xargs space options space command along with any initial arguments. Another trick is the backtick, which is used much like the same command. This is where everything between the backticks is treated as a separate command. To handle input or output redirects, you use symbols. Let's take a look at those next. The table on your screen contains the symbols that can be used along with the commands we've just discussed to redirect input and output. Certification candidates, yep, you'll want to commit these to memory. The greater than operator creates a new file with standard output. If the specified file already exists, it's overwritten. 2 greater than operators append standard output to the existing file, and if it doesn't exist, it's created. The 2 greater than operator creates a new file with standard error, and if the specified file exists, it's overwritten. A common use for this command is to send error output to dev null. Next we have the 2 operator along with 2 greater than signs. And this appends standard error to an existing file, and if it doesn't exist, it's created. The ampersand and greater than sign operator creates a new file with both standard output and standard error, and if the file already exists, it's overwritten. The less than operator sends the contents of the specified file to be used as standard input. 2 less than operators accepts the text on the following lines as standard input. And the less than and greater than operators together say that the specified file will be used as both standard input and standard output. On the next few slides, we'll take a look at using filters to manipulate files. So, what are filtering commands? They can combine files, they can alter the layout or format of a file, and also change how the data is displayed. Let's review some of these commands. The first is cat, short for concatenate. This command links files together, but can also be used to display files or add line numbers. -E or --show-ends displays line ends, and that's the $ at the end of the line. -n or --number adds line numbers to the front of every line. -b or --number -non-blank adds numbers only to lines that contain text. -s or --squeeze-blank compresses blank lines down to a single blank line. -T or --show-tabs displays tab characters as a caret sign. -v or --show-non-printing displays special characters using the caret and em- notation. The tac command reverses the order of lines in the output. Join combines two files by matching the contents of specified fields. Paste merges files line by line and its tabs separated. Expand will convert tabs to spaces. OD displays an octal dump, and that shows the files as octal numbers. Sort, as you may have guessed, sorts a file, and the options for sort are -f or --ignore case, -m or --month-sort, -n or --numeric-sort, -r or --reverse, -k field. Next is the split command, which takes one file and splits it into two or more files. The next is tr, which changes characters, and the format is tr space options space set1 followed by set2. Unexpand converts multiple spaces to tabs. Unique is one that I use fairly often, and it removes duplicate lines. Format, or FMT, cleans up the file format, and it has the options -width or -width space options. The NL filter is used for line numbering, and it has several options that let you tailor the output. The first is -b style or --body -numbering equals style, -h or -header -numbering equals style, -d equals code or --section -delimiter equals code, -p or --no renumber, -n space format or --number -format equals format. Then you have T for non-blank lines, A for all lines, N for no lines, and P for regular expressions. The PR filter is used to print a file, and it has several options as well. -D for double space, -L for line length, -H to designate a header, -O for the left margin, -F for form feed, and -NUMCOLS includes a column by that name. The next filter, head, allows you to view the first 10 lines of a file. Its options are -C space NUM or --bytes equals NUM. The next option is -N space NUM or --lines equals NUM. Conversely, the tail command lets you view the last 10 lines of a file. Its options are -F or --follow, -PID equals PID. The less filter we've used before, and if you recall, it lets you read a file one screen at a time. Cut will extract portions of lines and displays, Its options are -B space list, -C space list, and -F space list. WC produces a word count, a line count, and also byte counts. Its options are -lines, -words, -bytes, and -chars. Head and tail will be extremely useful as you get into perusing your log files. These files get really long, and so these filters will help tailor that output. Of this list, we've already used cat and less. Now let's head over to a terminal window and give some of these others a try. I know that I have a file in my Documents directory, so I'm going to use the CD or Change Directory command to switch over. Type in CD space capital DOCUMENTS. Now I'd like to know the word count stats for that file, so I'm going to type in WC space and the name of the file, which is user-manual.doc. You might have to substitute your own file name here. And if we hit enter, we'll see that the first field indicates the word count, then the number of lines, followed by the byte count and the name of the file. Now let's say we wanted to view the last 10 lines of a log file. First, let's type clear since our display is getting a little messy. Then we're going to use the Change Directory command again. We'll type in CD space /var/log. This is a directory that holds log files. And don't worry, we'll talk more about it a little later. For now, let's go ahead and require root privileges with the SU or switch user command. Type in your password. And from here, let's type in the tail command that we just learned about. And we'll type in messages. And you can see that I forgot the S, so let's go ahead and use that up arrow key that we learned about. We'll add the S on the end and hit enter. And what you'll see on the screen is the last 10 messages that are in the log file. Okay, let's head back to the presentation and look at file management commands. In reviewing the options and complexities of Linux commands, we would be remiss if we didn't cover some of the basics. These are the commands to let you do the simplest file manipulation tasks. Now there are a couple things to reiterate about files. Linux is case sensitive, so a lowercase l and an uppercase L are totally different. And certain characters shouldn't be used in file names, and those include the asterisk, the question mark, and the forward and backslash. These are reserved for special uses in Linux. The question mark is a wildcard and represents a single character, and an asterisk matches any character or set of characters. Brackets are used to match any character in a set. And we should also know that one dot refers to the current directory and a double dot refers to a parent directory. Now the first command we've used already, and it's ls, which again lists the contents of the current directory. CP copies a file from one source to a destination. MV moves a file. RM deletes. And touch modifies the timestamp or creates a file if it doesn't exist. mkdir creates a directory, and rmdir deletes a directory. Now let's move on to file archiving. The tape archiver command, or tar, is similar to the Windows zip command. It collects a group of files into a single zip file in Linux called a tarball. We'll cover the cpio and dd commands in a moment, but they have similar functionality. The table on the screen lists the options most often used with tar. --create, abbreviated with a C, creates the archive. --concatenate is abbreviated with a capital A, and that appends tar files to an existing archive. --append, abbreviated with the lowercase r, appends non-tar files to the archive. --update, abbreviated with U, appends files newer than what's in the archive. --diff or -- compare, which is abbreviated with a lowercase d, compares the archive to files on the disk. --list, abbreviated by T, lists the archive contents. And finally, --extractor --R or --get, which is abbreviated by an X, extracts the archive files. Let's move on to the next couple of slides that cover qualifiers and how they can be used to change what the commands do. Qualifiers, again, can be used to modify what the tar command can do. The first qualifier is --directory -dir, abbreviated by capital C, which says to switch to this directory before completing the action. --f, bracketed by host : followed by the file, abbreviated F, uses file on computer host as the archive file. --listed -incremental file, abbreviated with G, does an incremental backup or restore using the indicated file as a list of previously archived files. --1 -file -system, abbreviated with L, backs up or restores one partition. --multi -volume is abbreviated with a capital M, and it creates or extracts multi-tape archives. --tape -length -n, abbreviated with the capital L, changes the tape after the n number of kilobytes. And our last group of qualifiers begins with --same -permissions, abbreviated by a lowercase p, and that preserves all protection information. --absolute -paths, with the capital P abbreviation, says to retain the leading / on all file names. --verbose, with the lowercase v abbreviation, says to list all files read or extracted. --verify, with the capital W abbreviation, says to verify the archive after the write operation. --exclude -file has no abbreviation, and that says to exclude the indicated file from the archive. --exclude -from -file is abbreviated with capital X, and that excludes files listed in the indicated file. --gzip or --ungzip has the lowercase z abbreviation, and that says to process the archive using gzip. --bzip2 has the lowercase j, y, or capital I abbreviation, and that says to process the archive using bzip2. Let's move on to the dd and cpio commands. The dd command lets you archive a file system at a low level, which means you can copy a whole partition or a disk like a CD-ROM. This will probably come in very handy at some point in your career. The format is simply dd space if equals file space of equals file, where if stands for input file and of stands for output file. Now the cpio command is actually very similar to tar, but operates in 3 modes. The first is copy out, which is used with the -o or --create options, and it creates an archive and copies in the files. Copy in is used with the -i or --extract options and extracts data from an archive. Copy -pass, which can also be represented by -p or --pass-through, combines copy out and copy in, which lets you copy a whole directory tree from one spot to another. The table below lists other options associated with this command. The first is --reset -access-time. Abbreviated by a lowercase a, it means to reset the access time after reading the file. ~append, abbreviated with the capital A, appends data to an existing archive. Our CPIO options continue with ~pattern-file equals file name, and that's abbreviated with capital E space file name. And that says to use the contents of file name as a list of files to be extracted in copy in mode. ~file equals file name, abbreviated with capital F space file name, says to use the file name as the CPIO archive file. And ~format equals format, abbreviated with capital H space format, says to use the specified format, which could be bin, CRC, or tar. And oddly enough, the -I space file name abbreviation doesn't have an option per se, but that means to use the file name instead of the standard output. ~list, which is abbreviated with a lowercase t, says to display the table of contents for the input. ~unconditional, abbreviated with a lowercase u, says to replace the files without verification. And finally, ~verbose, abbreviated with the lowercase v, displays the files as they're added or extracted. Now let's move on with a look at process management. You start a Linux process by running a program, and sometimes these processes need to be manipulated. And for the kernel, Linux's first process, you do that with the uname command, which, as our luck would have it, takes the options listed in the table below. The first, -n or ~node name, displays the system's node name, which is also the host name. -s or ~kernel -name displays the Linux kernel name. -v or ~kernel -version displays the Linux kernel version, and that includes the build date and time. And -r or ~kernel -release displays the kernel version number. -m or --machine displays information about your machine. -p or ~processor will display info about your CPU. -i or ~hardware -platform displays your hardware platform, but usually this is unknown. -o or ~operating space system will display your operating system name. -a or ~all will display all of this information. Let's try out the uname command. Let's switch back over to our terminal window. First, let's type in clear. And then, since we're still logged in as root from our last operation, let's type exit. And that'll get us back to regular user mode. From here, let's type in uname, UNAME, space -n, and hit enter. And what we'll see there is the host name. Now let's try the -v option. We'll type in uname, space -v, and what we should see is the kernel name. Now let's take a look at all this information by typing in uname -a. And again, that displays all the information about the kernel. Looking at kernel information is fine, but what if we want to know about the other processes running on the system? For that, we use the ps or process status command. I use this command to find out information about errant processes. Now there are three types of options that go along with this command. The first is Unix 98, which uses a single character that can be grouped and is preceded by a single dash. BSD also uses a single character and can be grouped, but doesn't have a dash. And GNU long is multi-charactered, and it's never grouped and is preceded by 2 dashes. So the first option, as you can tell by the single preceding dash, is a Unix 98 type option, and that's a capital A or lowercase e, and this has to display all processes on a system. The X option can be used to display processes owned by the user who gives the command, and X can also increase the amount of information that's displayed about each process. -U space user or capital U space user or ~user space user displays processes owned by a user. -F, -L, J, L, U, and V expands the information. -capital H, -lower f, and ~forest groups and indents processes to show the hierarchy. -W, or W by itself, says to display the information wide, which is more than 80 columns. Let's take a look at that. Let's switch back to our terminal window, and we'll type in clear to start over with a fresh screen. Now let's type in PS space dash capital A, and this should display all of the processes on the system. And you can see that's a pretty long list. Now let's try PS space dash capital H, and that should give us a hierarchy view, and it shows that the processes are bash and PS. Another process command is jobs. Now it isn't one that I use very often, but it is still something you should understand. What it does is display a small amount of information about the processes associated with the current session. Most useful of those might be the job ID, which is sometimes used in place of a process ID. Jobs can also help you determine if you have any programs still running before you log out. The next, and one that I use more often, is the top command, which logs CPU usage. It takes the info from PS and sorts by the programs using the CPU the most. You run it by typing top at the command prompt, and yes, it takes its own options. -D space delay is the delay between the output updates. -P space PID monitors specific processes. -N space ITER displays the number of updates indicated by N and then quits. -B is for batch mode, which says to use the file instead of a screen. H and question mark access help. K says to kill the process, and Q quits. Continuing our review of top options, R changes the priority, and that's based on the process ID and the new number. S changes the display update rate in seconds. Capital P sorts by CPU use, and this is the default option. Capital M says to sort by memory use. Now let's take a look at foreground and background processes. So we know that when we run a command at the shell prompt, during the time that program is running, you can't do anything else in that particular shell window. That's because the program is running in what's called the foreground. But if you wanted to, you can launch the same program in the background so that you might complete other tasks while it's running. To run in the background, just append the ampersand character to the end of the command. As you can imagine, Linux is running tons of processes at any given time. And we saw that in the output of the PS command on our previous demonstration. So if a program is already running and you want to send it to the background, hit Ctrl-Z, then type in BG, and that will send that program to the background so that you can complete another task in that same terminal window. And consequently, if you want to bring it back to the foreground, you type in Ctrl-Z and then FG, which will bring it back. You can also launch a program with a certain priority. To do so, you use the nice command. And to alter the priority on a running program, you use renice. The syntax for nice is simply nice, followed by the argument, followed by the command, and any command arguments. Now the argument is the priority, which could be assigned using a dash and a number, a dash in and the number, or double dash adjustment equals and the number. And the number, of course, is the priority that you want to set it to. Renice, again, will alter the priority of a running program. The syntax is renice, followed by priority, which are the same as those for the nice command, followed by any process IDs, or group IDs, or users. And most of the time it will be one or the other. Now we should also note here that only root can increase the priority of a running program. If you want to kill a process altogether, you use the kill command. The syntax is kill space -s space signal followed by the process ID, where S signal is a name or number. And those options are SIGHUP or number 1, which terminates the program. 9 or SIGKILL causes the process to exit without performing any of those shutdown tasks. And 15, which is SIGTERM, lets the process exit and close any open files as well. If you don't specify a signal, the default is 15. Kill all is another option, which terminates a process based on the name rather than the process ID. Now let's take a look at regular expressions. Regular expressions simply represent patterns of text. The word Linux itself is a string, but things can get advanced when you combine the string with non-alphabetic characters, which can expand the matching rules, kind of like the wildcards we talked about earlier. The first of these characters is the brackets. Anything inside the brackets is a bracket expression, which matches any one character that's in the brackets. So, for example, if we had the characters A, E, and I enclosed in brackets between a C and a trailing R, this would match both CAR, CER, and CIR. The next is a range, and that's included inside brackets, but is separated by a dash. The single character is represented by a dot and matches any single character in a group. For instance, C.R is equal to CAR, CBR, or CDR. The start of a line is indicated by a caret symbol, and the end of a line by a $sign. Repetition is a special symbol that marks how many times a matching item should exist. Asterisk represents 0 or more times, the plus sign 1 or more, and the question mark is 0 or 1. And these can be combined with other characters as well. Multiple strings is represented by the vertical bar, and it separates two possible matches. Parentheses mark sub-expressions, and escaping is represented by the backslash, and that's used to match a special character like a dot or a question mark. Now there are two programs that use regular expressions quite a bit, and those are grep and sed. Let's start with a look at grep. Grep searches for files that contain a particular string. The syntax is grep space options space regular expression followed by the files. And of course there are a few options. -C or double dash count, -F space file or double dash file equals file, -I or double dash ignore dash case, -R or double dash recursive, and double dash extended dash regexp. We review commands that let us manipulate files, and sed continues in this vein. It actually modifies the contents of files and sends the updated file to standard output. There are two syntaxes associated with this command. The first is sed, S-E-D, space options, space -f, space script-file, space input file. The second is sed, space options, space script-text, space input file. Input file is the name of the file you want to change, and script text and script file are the commands or actions you want sed to take. The table on your screen outlines these commands. The address column represents a line number. None says to operate on the entire file. 1 represents a line, or 2 addresses represent a range. A typical sed command could employ the use of the backticks that we talked about earlier. It might read sed space backtick s, which represents a regular expression, /blue /green, followed by the trailing tick, space colors.txt, greater than symbol, space new colors.txt, which says we're going to look in the colors.txt file, and we're going to swap out the word blue for green, and we're going to write that to a new file that's called newcolors.txt. Let's take a look at some options that go along with this command. Equal displays the current line number. /text appends text to a file. I/text inserts text into a file. R space file name appends text from file name into the file. Continuing our look at sed options, C/text replaces the selected range of lines with the indicated text. The next one we just learned about, and it's S/regexp or regular expression /replacement, and that replaces the text that matches the regular expression with the indicated replacement. W space file name writes the current pattern space to the file. Lowercase q will quit the script but print the current pattern space, and upperspace q quits immediately without writing. Another useful command is tr, which is used to convert from DOS to Unix. The syntax is tr space -d space /r space less than space the name of the DOS file space greater than space the name of the Unix file. Now let's wrap up this lesson with a look at the Vi editor. I'm sure you've heard of the browser wars, but they stand in pale comparison to the Linux editor wars. Some people will swear by Emacs, some gedit, and some others, but you'll find a large community firmly and unwaveringly supporting Vi. I guess that's because it was the first editor written for Unix, and that legacy is still evident. Vi is small and nimble, and it's perfect either for use on an emergency boot disk or as a full-fledged web development tool. For those of you who are not faint of heart, of course. Being the curious person that I am, I tried Vi, but ended up using a combination of tools. I'll warn those of you who like GUI editors, Vi will be a bit of a shock to the system, but as an administrator, and also as someone interested in Linux Plus certification, you'll need to get very comfortable with it. Instead of Vi, you may have Vim, which is a new improved version of Vi on your system, but the material we'll cover will apply to both versions. The most basic concept you need to understand is Vi's 3 operating modes. Command or normal mode accepts single-letter commands. X or EX is accessed by typing the colon, and it's also referred to as colon commands. This mode is used for file manipulation, like saving your document and launching outside programs. Insert is used to insert text. You access this mode with either the I or A from the command mode. And the escape key always exits and returns you back to command mode. So if you ever lose track of where you are, the escape key will take you back to that mode, and you can navigate from there. There are many commands and combination of commands that can be used to help you navigate from within Vi. The first of these is H, J, K, and L, which represent the left, down, up, and right arrow keys respectively. Yank works much like Windows copy command, and the syntax is the number of lines followed by 2 Ys. YX will copy the amount specified by X. DD works just like Yank, but it deletes the lines and copies them to the buffer. DX deletes the amount specified by X. Lowercase p says the pace after the cursor, while the uppercase P says the pace before the cursor. The tilde changes case, U undoes the last command. In command mode, the O will insert a new line below the current one and enter insert mode. And the colon exclamation point will execute an external command. Continuing with our navigation keys, the /, when used in command mode, is used to search for text. Lowercase c changes text from within command mode. CW can be used to change the next word, or CC can be used to change an entire line. Capital G says to go to a specific line. Capital H is for home, and capital L is used for the bottom of the screen. The next command replaces a string and does it globally, and that's %s /original /replacement. :E says to edit a new file. :R includes the contents of an old file in the new one, and :LS lists the directory. And we have some save navigation keys as well. :W saves, 2 colons and a Q or Q and an exclamation point will quit without saving, and :WQ will save and then quit. Now Vi is a very powerful program, and as such it definitely has more commands than what we've reviewed here. This is a program that will take a little getting used to. To help reinforce this information, I decided to use Vi exclusively for a couple weeks, and the same may work for you. And that concludes our lesson on GNU and Unix commands. Let's review what we've learned on the next slide. I hope you feel yourself getting more comfortable with navigating the command line. And though there are usually ways to accomplish the same tasks from the GUI, an administrator must be proficient in working in both environments. In this lesson, we covered some basic operations associated with the Linux command line. Then we moved into manipulating files with pipes, streams, and filters. Next, we reviewed file management and process management commands. Next, we learned about regular expressions and how they can be used to search and modify files. We wrapped up with the Vi editor, an essential tool of the Linux administrator. Thank you for watching, and I'll see you in the next lesson.